Imagine searching for a specific book in a vast library without a catalogue. You would have to check every single book, which would take an incredibly long time. This is how a database searches for data without an index. It has to scan every row in a table, which is inefficient and slow, especially for large data sets. This is where database indexes come in. An index is a data structure that speeds up data retrieval. Think of it like the index at the back of a book. It lists important terms in alphabetical order and tells you the exact pages where you can find them. Similarly, a database index stores a sorted order of specific columns and pointers to the actual data rows in the table. When you query a database, the database management system uses the index to quickly locate the relevant data, significantly reducing search time. Without indexes, the database would have to perform a full table scan, which means checking every single row in the table until it finds the matching data. This can be very time-consuming, especially for large tables. Indexes help to avoid this by providing a direct path to the relevant data. Database indexes offer significant advantages in terms of search speed and overall database performance. The primary benefit is faster query execution. By using an index, the database can quickly locate the data that matches your search criteria without having to scan the entire table. This is particularly beneficial for queries that involve searching for specific values, ranges of values, or sorting data. Another major benefit is efficient sorting. When you create an index on a column, the database stores the data in that column in a sorted order. This means that when you query the database and request the data to be sorted by that column, the database can simply retrieve the data from the index in the required order. This is much faster than having to sort the entire table on the fly. For example, imagine searching for a product on an e-commerce website with millions of products. Without an index on the product name column, the database would have to scan millions of rows to find the matching products. However, with an index on the product name column, the database can quickly locate the relevant products by using the index, resulting in a much faster search experience for the user. While indexes are powerful tools for improving database performance, it's crucial to understand that having too many indexes can be detrimental. One significant drawback is the overhead on write operations. Every time you insert, update, or delete data in a table, the database must also update all the indexes associated with that table. This means that having too many indexes can slow down write operations significantly. Another drawback is increased storage needs. Indexes require disk space to store the index data structure. The more indexes you have, the more disk space they will consume. This can be a concern, especially if you have limited storage space or are working with large data sets. Furthermore, excessive indexing can lead to performance issues during index maintenance. Databases need to perform regular maintenance tasks on indexes, such as reorganizing or rebuilding them. When you have a large number of indexes, these maintenance tasks can take a long time and may even require downtime. Finally, too many indexes can overload the query optimizer. The query optimizer is a component of the database management system that determines the most efficient way to execute a query. When you have too many indexes, the query optimizer has to consider more possibilities, which can slow down the query planning process and impact overall query performance. To reap the benefits of database indexes without falling prey to their drawbacks, it's essential to follow best practices for effective indexing. The most important practice is selective indexing. Don't index every column in your database. Instead, focus on indexing columns that are frequently used in search criteria, join conditions, or sorting operations. Consider creating compound indexes for queries that involve multiple columns. A compound index is an index that spans multiple columns. It can be more efficient than having separate indexes for each column, especially if these columns are frequently used together in queries. Regularly review your indexes to ensure they are still necessary and being used effectively. As your database and application evolve, the usage patterns of your data may change. Indexes that were once beneficial may become redundant, while new indexes might be needed for optimal performance. Finally, monitor the performance of your indexes using database monitoring tools. These tools can provide insights into which indexes are being used, how often they're being used, and how much they're impacting query performance. This information can help you identify and address any indexing issues that may arise.